double checking that you can see the board and hear me okay. What we're doing today is that last third of the test number 6. So we're gonna still give you 10 minutes per section, but that's with the understanding that the explanations might take a little bit more time as we get nearer the end. And so try to complete as much as you can in the 10 minutes, but we are also taking that time to explain. And so we will definitely have the time to work on stuff, so don't hesitate to ask questions. A couple of these, again, I want to use as springboards to talk about not just that question, but related topics with that question. So it's on page 447 of your 10 test book, is where it's hiding. I do encourage you to have the calculator. We'll take this time as a public service thing that...
You're on mute.
Oh, I swear I hit unmute. I apologize. That's why we do this warm-up. Thank you for telling me there was a notification in the way about the Zoom meeting. Anyway, I was saying we're on page 447. We're going to finish our 10 test number 6 for math. We're going to be doing the 10 minutes and 10 problems again, but especially because it's near the end, I'm anticipating the explanations will take a little bit longer, and so that's what we're going to be finishing today. And do not hesitate to ask questions, because the more you ask, the better directed our review of those questions is. Yes?
I forgot to grab my calculator from school. Is there any chance that you have an extra?
I do not. So, also public service story. I took the ACT without a calculator my senior year. I was retaking the test because my first test, the English score had not been good. And so I knew I could do better on the English. And so I took it, and my English score went up and my math score went down, and my score was right exactly where it was. So I got a 32 and a 32 again. So it is entirely possible to take this test without a calculator, but it tends to be a little bit more convenient. For the purpose of practicing, I would go ahead and just use your phone. But public service, don't forget your calculator, pack your bag the night before. But the other thing I was going to mention was also make sure that you put the calculator away off of the desk any other time than the math. It is allowed during the math portion of the test, but it needs to be away off the table during any other of the other ACT testing points. And so those are the two things. Oh, third one, bring a backup calculator if you can. I have also proctored a test and watched somebody have their calculator batteries die. And the light in their eyes dies as well, and it's a horrible, horrible feeling. But it doesn't matter how sympathetic the proctors feel, they cannot give you a calculator. It is against the rules, and technically I don't think you could borrow one from another person either, and so even if you have a friend there, they can't loan you one. So very strict. Have a backup, even if it's like a 10 function calculator. Sorry, not 10 function, 4 function. Add, multiply, subtract, divide. Again, it's possible to do with a minimal calculator. Even when they talk about sine, cosine, and tangent, frequently they give you values for those. And so it's possible, but not encouraged. Good questions. Any questions from online other than, hey, you're muted, and I apologize for that. All right. Unfortunately, the iPad is turned off. Didn't realize that. So go ahead and begin. I'll stop you in 10 minutes. right, go ahead and go back to your 41. We're going to check it first and then talk about them. For 41, your answer should be D as in dog. 42 is F. 43 is B as in boy. 44 is K. 45 is B as in boy. 46 is H. 47 E as in elephant. 48 K. 49 B as in boy. And 50 G as in girl. All right, what questions do you have to begin with? Yes.
So, again, I'm only in modern geometry, so I don't know what imaginary numbers are.
Okay, so imaginary numbers are based in one particular thing. Imaginary numbers are the idea that we know that if we have -3 and we square it, it goes to +9. And we know that if we had +3 and we squared it, it would still go to +9. And so you have been taught that the square root of negative numbers doesn't exist. There's just not a number that multiplied by itself gives you -2. But what we do with that is break this up into -1 times 2. And the imaginary number is that if there was the square root of -1, it would look like I. And so it's defined the square root of -1 is I. That's the imaginary number. And so this is in reference to that quadratic zeros question.
44.
So on 44, quadratics break up into 3 possible categories. So if you are looking to make your ACT score higher, one of the things that I highly encourage is memorizing the quadratic formula. And so this is -b plus or minus the square root of b squared minus 4ac all over 2a. And so this gives you the values of the zeros, or the values of the roots for any quadratic. But it's also a 3-for-1 deal. The first deal is it gives you the roots, it gives you the zeros, it gives you answers. But if you look at the pieces, this part out front, -b over 2a, gives you the axis of symmetry. It tells you where the middle of that graph is, because this plus or minus is the wobble in each direction. And so this part right here gives you that exact center. The other thing that it gives us is this part underneath the square root gives us the discriminant. Because if this is a positive number, we're taking plus or minus a positive number, that's going to give us 2 roots. And so back to black. If we have 2 roots, the graph is either going to look like this, oops, bad drawing, or it's going to look like this. But either way, this is 2 real solutions, because there's one right here and there's one right here. If this had been 0, then we're plus or minus 0. There's only one possible answer, because plus 0 or minus 0 doesn't change anything. And so what that looks like is if there is one real answer, it touches just once. And so that is our answer, and there's only one of them, and that happens with plus or minus 0.
So if you had looked at this, you could have immediately determined that it was 2 real solutions because
Yep.
it touched twice.
Because it touched twice.
So is this a question that's on most tests?
This one's pretty common. Whether it's the two real solutions, I can't guarantee it's that answer, but something about the nature of the roots, that shows up a lot. And sometimes it's with the graph and sometimes it's with the equation, and you'd have to be able to tell what kind of answer you would be getting.
And if I just solve out that, could I just solve out the square root?
Yes.
See if it was...
And so if you just put this in, you don't even have to worry about this other stuff, just this part on the middle. If you get a positive, there's two real roots. If you get a 0, there's one real root. If
So
you get a
it'll never
negative,
be-
that's the imaginary.
It'll never be a double imaginary or two imaginary solutions.
So it would be two imaginary. Because if this ends up being negative, I don't know, 9, we'll go for a perfect. That would root down to that 3i. But remember, it's still this plus or negative. So it's plus 3i, negative 3i. That's making 2 imaginary roots. And the way that that one looks is when it's floating up above or below the graph.
So
There's
when-
no real solutions because it's never touching, but there are 2 imaginary. The 2 that are not possible, you can't have one real and one imaginary. That's never going to happen. And you can't have one double imaginary. That doesn't count. So the one double root is this one, because it's the plus 0 minus 0. What happens with that, if you did the factoring, would be like x plus 3 times x plus 3. When we have a squared piece like this, then this has a double root at negative 3, because negative 3 makes this and this. That's what the double root is talking about.
So if it touches twice, it's 2 real solutions. If it touches 1, it's a double imaginary solution.
If it touches once, it's a double real. It's
oh,
real because it's on that
Okay.
line. Imaginary is there aren't real solutions. There's not a number we can plug in that makes 0.
Okay.
Excellent questions. This was one of the ones that I wanted to talk about beyond just this question, because it is fairly common to see something about the nature of roots. Another thing, they might give you a list of pictures and say which one shows 2 imaginary solutions. And so you'd be looking for the one that doesn't cross the axis, that doesn't have real answers. Oh, somebody came in late. So that is the nature of roots. All right, any other questions from 41 through 50? 41 is dealing with exponents. That key that we want more than anything else is that if I have the third root of a, this is equal to a to the 1/3 power. And so roots are fractional exponents. If you can do that conversion, it gets pretty simple. 42, it's just solving for a different variable. It's presented as a trapezoid problem, but in reality, it's just being able to solve for a different variable. 43, it's picking out a point and turning it into a rate. Not bad at all. 44, we just talked about. So, did you just plug in answers for 45, or what was your solving technique on that one?
I didn't know how to do
I just, the answer, what was the answer for 45? Just so I know if I'm wrong. It's B, right?
Yes.
So I just kind of knew that, that if we put plus negative 6, it would subtract,
6.
12, subtract 6 from 12, and then that would equal the positive version of it. So.
Yeah. Guessing and checking, trying out, does that work from the answer bank? Those are all valid techniques on that one. All right, how about 46? Were you using fractions on calculators? Were you changing it to common denominator? How were you finding 46?
I cook a lot, so I just kind of could figure
Okay, so you knew it. That's fractional instincts will serve you well. Anything you can take in to the test as a I've got this. Hey, that's great.
I have to
So-
figure out that stuff all the time quickly.
So the thing that I'm going to remind you with exactly halfway is if you need halfway between something, whether it is exactly halfway or if they've presented it as a midpoint, both of those things are averages. And so what you are doing is you are taking, it's 1/3 and 1/2, so you're taking 1/3 plus 1/2 and dividing by 2. And so if you need exactly halfway between something, you're just averaging it. If you need the midpoint of something, you're just averaging it. And so knowing that is the key to this problem. Beyond that, lots of people have calculators that can do that, or you can do a common denominator with it, but know that halfway is the average. It makes your life easier.
Would you say that that's kind of a common question on?
Something to do with averages, absolutely. I haven't seen it with the fractions as much. That's a little bit of a curveball. But the idea of the average or the midpoint or the mean, all of those things are all over the place.
Oh, so you
Mean, median, mode, be confident with them. You can finish your question.
Oh, I just realized that like the midpoint, that like you can find a midpoint with average.
Uh-huh.
But, like I just realized that like the midpoint.
The midpoint formula, yeah,
explanation
it's the
is just
average of
this.
X and it's the average
Yeah,
of Y.
okay.
It absolutely is. And so the more you can like understand what's going on, the fewer formulas you have to memorize. Understanding trumps memorization all the time. Except when it's the quadratic formula. That one I don't want to rederive every time. All right. So 47. It's kind of similar to that absolute value question. If your brain can't intuitively understand what's happening, this is a classic problem where I would say pick a number. It doesn't matter what it is. You could use a variable, but I would be inclined to say pick a number and pick an easy number. Pretend the budget is $100. We know it's not, but just pick one. And then she says we're supposed to record an expense. If we're recording an expense, what are we supposed to do?
Subtract.
Subtract.
And so just pretend if we did subtract, we would be at 80. And I can't write today. If we add instead, we're at 120. So what's the difference between those two? It's $40.
Yeah.
And since this is what's recorded, it is 40 more than it should have been. And so if you try and juggle variables in your head, sometimes it makes a problem a lot more difficult. You can pick any number you want. Pick an easy number.
So you can, because I've wondered that about a lot of equations. I'm just like, it doesn't give you.
Yeah,
what
when
the
it
number
talks
should
about
be.
the x goes up by 2 and y goes down by
Yeah.
1, just pick numbers.
Okay.
And you can even pick 0 for the original, and then 1 is now 2 and the other one's -1, and it makes the difference really obvious. So yes, picking numbers is an absolutely great solving technique. All right, 48. By name, how many of you have heard the word permutation? Anybody online? That's okay, you don't have to know it by name to talk about what's going on. So, Rebecca is trying to schedule volunteers. There are 1, 2, 3, 4, 5 time slots. And there are also 5 volunteers. So, how many people are available to schedule for the first shift?
5.
All 5 of them. How many people are available for the next one?
4.
And you're just going to multiply down the line. This is 5 times 3 times 4 times 3 times 2 times 1. And that's how many different combinations of schedule are possible. There is a way to write this, This is called 5 factorial. So it may be in your calculator or not. It was on the TI 89 once upon a time, and I learned about it on a test, not the ACT, but a different test that I got introduced to it, and then I asked my teacher about it later. But factorial is written like this, and so if I have, I don't know, 4 factorial, this means 4 times 3 times 2 times 1. Yes?
So like, what if there's a question where it's like making a sandwich and it's you can choose the cheese and then you can choose the meat and
Okay.
there's like 2 different categories.
Okay, so that one, it's how many possibilities for meat, how many possibilities for cheese, how many possibilities for bread, and you just multiply those options.
Don't use the exclamation mark.
No exclamation mark on that one.
Okay.
The exclamation mark is about repeating from the same pool.
So if it's just if there's 3 meats, 3 spreads, and 4 cheeses, then you just do 3 times 3 times 4.
So it's the same process as if you didn't use the exclamation mark?
Yes, but this one, because they're coming from the same group, these are 3 from one group, 3 from a different group, 4 from the final group. Versus here, these are 5 options. We've used up 1. Now there's 4 options left, 3 options left, 2 options left. So the other thing to be aware of with factorial is let's take our 5 factorial and divide it by 4 factorial. Remember, 4 is just going to be 4 times 3 times 2 times 1. And so these all cancel. And so 5 factorial divided by 4 factorial is just 5. If I have 5 factorial divided by 2 factorial, it's everything up until 2. So it's 5 times 4 times 3, but then the 2 and the 1 would get canceled off. And that is our answer. So factorials, yeah, it's hit or miss. I have seen them, but not quite as consistently as some of the geometry stuff or the quadratic stuff. But it's good to know because once you know it, it's really easy to work out. It's just, maybe you've never seen that written down before. So permutations are all about how many different ways to arrange things. Combinations are about things in a group, but I haven't seen that one on the ACT as much, so we'll leave it at that. All right, 49. Whether you have seen the word geometric sequence or not, what was the pattern? What was happening?
Divide by 1.5.
Uh-huh. So, which one is the closest to that? Because a geometric constant is about multiplying. So if we're dividing by 2, what are we multiplying by?
2.
Divide by 2 and multiply by 2 isn't the same. Dividing by 2 is the same as multiplying by 1/2. And so you can see the pattern that's going on, but be able to recognize that into multiplication.
Sorry, this might be a dumb question, but why can't you just do times 2? Why do you have to do times 1/2? If you're...
Because it moves from the left to right, the direction we read. And so we had 3, and then 1.5, and then 0.75. If we were multiplying by 2, this would be 3, 6, 12. Multiplying by 2 and multiplying by 1/2 goes in the opposite directions.
So if it was going the other direction, it would be times.
If you had started with 0.75 and then it was 1.5 and then it was 3, we would be multiplying.
Okay, that makes sense.
That's where I got it wrong.
So paying attention to that direction, it's the order that we read in. Yeah. All right, 50, very much just a plug in values into the calculator.
It actually gave us the equation this time.
Yeah, ACT is really kind of flaky. Sometimes it gives you the equation, sometimes it doesn't. It depends on whether it's testing your knowledge of
How
the
do we-
equation or if
Yeah.
it's testing your
How
knowledge
do
of
we
something else.
memorize all those equations? Because we've never really had to do that, and there's so many different ones.
All right, we are going to take the time because that is a good question and it's something that shows up on the ACT all over the place. So, what's the area of a rectangle?
X times Y.
Length times width. Okay, next one. How about a parallelogram?
Oh, I forgot.
X times Y divided by point.
I know
You're thinking triangle.
it's divided
So,
by something, isn't it?
We can chop this off,
Oh.
move it over here,
Oh,
and turn it into a rectangle. It's
So
literally
it's-
length times height. How tall is it? How long is it? It's just a rectangle. How about a triangle?
that's length times height divided by 1/2.
Divided by 2? I know what you're going for.
Divided by
You
2.
you either have to multiply by 1/2 or divide by 2 because it's literally half the rectangle. The classic one, they really like trapezoids. I was kind of surprised that they gave you the formula for trapezoid in here because frequently they like to throw trapezoids.
So isn't that just height times the top times the bottom? Or
Close. It's back to that middle thing that we were talking about. The middle is the average. So this is called base 1 and this is called base 2. It doesn't matter which is which. It's just talking about the two parallel sides or the bases. And what you are doing is taking base 1 plus base 2 and dividing it by 2. You're finding the average of these two because that's right here in the middle. And then we are literally chopping this one off, putting it up here, chopping this one up, putting it up here. We're turning it into a rectangle, so you're going to take the average of those two bases divided by 2 times the height. And so with the formulas for area, it always just comes back to a rectangle. Even a circle, the distance around or the circumference of the circle is equal to 2 pi times radius. If we chop all of these things up into tiny little sections, bad drawing, but
Did
you
we
know,
have a question like that last time?
possibly. But what happens is that we can line up all of those little triangles into, like, I think of it as the circus design. But what happens is that this is half of the circumference on the top and half of the circumference on the bottom. So this is just pi r length. And the height is the radius. So the area of a circle is equal to pi times radius, or radius squared. It is also a rectangle. My key on these two is most people tend to remember these really well, but then they start mixing them up in their head because they're like, it's the one with pi, but which one with pi? Area is measured in squares. Area is the one that has squared in the formula. All right, and of course we are crunching on time. I knew that was going to happen on this last one. So, go ahead and take 10 minutes. You may begin. apologize. I'm going to cut you off just a little bit early so that we can have time to talk over more. So, grading at the end, 51 would be C as in cat, 52 is G as in girl, 53 A, 54 K, 55 D as in dog, 56 F, 57 E as in egg, 58 F, 59 C as in cat, and 60 J. So I don't know that we will have time to go over all of these, so your questions become more important.
What is log?
Log?
The value of log.
Log is not a value, so which one is that?
60.
60.
The value of log is, the value of log 5 is 5
Okay.
times 17.
So
Yeah.
log base 5 of 5 to the 17
Thirds.
thirds. So log is the undo of exponent. So if you had x to the third equals, I don't know, 8. Log is, oh sorry, it should be 3 to the x. Log is how you solve for things that are in the exponent. And so what happens is the base of this exponent is 3. And so we say the log base 3 of 8 equals x. And so this gets pulled down to the log. And so every mathematical operation has its undo, like square and square root, add and subtract, multiply and divide. Log and exponent are the undo of each other.
So if I were to type that into my calculator, I would find out what x is, right?
Except unless you have a menu, I don't know that it does log base 3. So I'm going to teach you what to do with that. Most calculators have a log button that just looks like this. It's called common log, and it is assumed to be log base 10. And so if you have log base b of a, what you can do with the calculator is log common log, I'm just going to write the 10 so we know that it's common log, but this common log in your calculator of this thing, a, divided by the log, common log, again the 10 of b. And so that is the formula that converts from any log to one that you could do in your calculator.
So you can't just directly like press log and then there's like a little box for you to
No,
put
there's
3.
not really a little box to put the 3 in.
Is that because the ACT requires it to be like that?
I
Or is that just,
honestly
like, a
don't know.
calculator thing?
This formula is easy enough that most calculators don't bother programming anything other than the 10. It's possible that there's a program buried in some menu that would do it because the calculator can then use this formula, but they don't specifically save it because that's what's going on with your square roots, with the logs. The calculator is just saving a giant table full of numbers and then pulling them. So with this change of base formula is what this is called. Base goes on the bottom is the best way to remember that. And so it's the log of the base on the bottom, the log of the value on the top.
And that'll get you what like x equals?
That would get you what x equals.
Okay.
So with the problem that you are discussing, however, remember that this base is the exponent. And so we can write this as an exponent, and what's going to be is 5 to the 17 over 3 is equal to 5 to the x. These 5s are the same. They cancel each other out. And so x just equals 17 over 3. And it's a question of, okay, which numbers is that in between? 17 divided by 3, it's not quite 18 divided by 3, but it's more than 15 divided by 3. It's going to be in between 5 and 6. Good question. Mini lesson on logs. the ability to rewrite them and that change of base formula is the most common things to see with those. I see a log problem in about 1 out of 3 ACT tests. So it's a reality that it might be there, but not a guarantee that it will be. All right, any other questions?
Are negative numbers real numbers?
Negative numbers are definitely real numbers. Good question.
So, my question is just 55 in general, because
55 or 53? Both of them are.
yeah, 55 first.
Okay, so which of the following are equivalent to the mathematical operation of A times B minus C? And so let's just take it from the top.
Oh, what I did with that one is I just distributed A to see
Okay.
what that equals.
So if we distribute A, what do we get? We get AB minus
AC.
AC. So if we look at the first option they offer us, the CA and the minus BA, the subtraction's on the wrong one.
So
And so that would be no. So 1 is out. If we look at 2, that's exactly what we've got. If we look at 3, does it matter if we multiply it at the back rather than the front? No. And so 2 and 3 are both valid.
Wait, alright, now can you go to number 53?
So for 53, so it's talking about any number, positive or negative, doesn't matter. But when we talk about the square root of negative number squared,
That turns into a positive.
that turns it into a positive.
And
And talking about turning it into positive, we represent that as absolute value. And so both of these two would be the same.
so if it's a positive and then a square root, it's a real number. Got it.
Mhm.
So,
And both of these make positives, but a negative in front of my absolute value, that makes it automatically negative. And so this is not the same. If we pick 2, throw a negative in front of it, that's going to be negative 2. But then we square it, becomes 4. Take the square root, it goes back to 2.
for that last one, but I thought you said that negative numbers aren't, or are real numbers. How is, because can't you like put the, like 10 and then absolute value and then the negative sign in front of it and it'll give you a non-imaginary number?
So the negative, so let's take 10. So if we throw the negative in front of it, we get negative 10. We square it, we get 100. We take the square root, we get back to 10. We throw 10 in here, absolute value of 10 is just 10. But if you throw 10 in here, absolute value is still 10, and then throw a negative, it becomes negative 10. So the question wasn't about whether they are real numbers, but which are equal for all real numbers.
Oh,
It's
okay.
talking about not necessarily does it give you a real number, but are they the same real number as what you had before? If you had negative 2 becomes negative 2 or positive 2. Positive 2 squared is 4, and then we're back to 2 again. If we throw 2 in negative 2 in here, negative 2 absolute value again becomes positive 2. And so it doesn't matter if you start with a positive or negative number, those go to the same thing. All right, time for one more. Anybody from online? I don't want you guys to feel left out. Had some good questions. All right, you
I
get
have
it.
one really quick question. So I'm in geometry this year, so
Mhm.
I just forgot the equation for 52.
Okay, so 452, the idea is that any polygon can be broken up into triangles. And so in this case, we've got a hexagon. What you do is you start at one corner. These two will not make a triangle because those lines are already drawn. But all the other lines break it up into as many triangles as sides minus 2 for those two sides.
That's what it was.
And then those triangles, so the sides minus 2 gets multiplied by 180 for all the triangles. And then for one angle, because it's regular, it's all the same, we just divide by the number of sides, which in this case is 6. But hexagons in particular, it might come up that you want to memorize this. If it's a regular hexagon, what happens is that it makes equilateral triangles all over the place.
So if you really just take 2 angles,
So it's just going to be 60 and 60 makes 120.
that's what I did.
And so being familiar with that regular hexagon, it's a shortcut that gets to show up. All right, one more. All right, then general hints. If you look at 51, the side length of the little triangle is 4, and the side length of the bigger triangle is 16. How do you get from 4 to 16?
4 to 16? Oh, because
4
it went
times
from
4.
the small one.
Mm-hmm. So you're multiplying by 4.
Yeah.
So that is the scale factor of the length. If you talk about area, the scale factor gets squared. So just like area is squared, the scale factor gets squared. And so the length was 4 times as big. The area is 4 times 4. It's 16 times as big. And so you take that 8 area that they told you, and you multiply by 16 to get the area of the big one. And so that's where that one comes from. With 54, you can solve it like a quadratic and just ignore the b until the very end. And so you solve the quadratic of x squared minus 4x minus 45. And that's how you would solve that one. 56, I don't think we're getting into trig identities. Very inversely means that the two variables, in this case a times b, equal some constant. And so you would multiply the 36 times 12. And then you're solving it that equals 48 times a. And so that's what you're solving there. So varies inversely means that the two together multiply to a constant. Direct variation says that y equals some constant times x. As x gets bigger, y gets bigger. 58, that one is getting back to that discriminant, kind of a harder question about what solutions. For which of the following values of c will there be 2 distinct real solutions to the equation 5x plus 16, or 5x squared plus 16x plus c? And so that's b squared minus 4ac. You're trying to plug in those numbers and figure out, okay, which value of c would give me a positive answer. All right. I feel like we talked about the composite functions last time, so 59 shouldn't have been too scary. And then we already talked about 60. Excellent. I know I talked really fast. The video is available and should be posted by the end of tonight. Go ahead and turn me down to 0.75 speed. I will not be offended. I just wanted to get through everything. So the other one is you can text me on the WhatsApp for individual questions and I will write out answers. So do not hesitate. I will be back at the beginning of April. All right. We're gonna pause online.